Today we're going to look at doing significant tests of a population proportion. The conditions for doing a significance test for a population proportion are random, 10%, and normal. The same conditions that we had for confidence interval. For the normal condition, we use n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10. Remember, n times p is successes and n times 1 minus p is failures. Okay, we use p because we assume h sub o is true, which we'll get into in just a minute. But we use p instead of p hat. The test statistic for a population proportion, this is at the bottom of your notes, the test statistic for a population proportion is z equals p hat minus p divided by the square root of p times 1 minus p divided by n. Okay? It's kind of sort of on the formula chart and kind of sort of not. On the formula chart, I think it tells you it's statistic minus parameter divided by standard deviation of statistic. But the good news is you really don't have to memorize it because you won't have to use it on free response questions. All right, calculator steps for doing a significance test for today. Here's the calculator steps. You're on a calculator page. You press the menu button. You choose statistics, stat test, and one prop z test. That's the calculator steps. All right. 4 steps for conducting a significance test. 4 steps for conducting a significance test. It's the same state, plan, do, conclude that we had for confidence intervals. It's just what we're doing for each part kind of changes a little bit. So the first step is state. Define parameters, state hypotheses, state significance level. For plan, you name the inference method and you check conditions. That should be the same as it was for confidence intervals. You name what you're doing and then you check the conditions. For do, you perform calculations. You're going to write down your test statistic and your p-value. So the calculator is going to give you a z and a p-value, and you're going to write both of those down. And then for conclude, you interpret the results in context of the problem. Okay? All right, so let's look at an example. On TV shows like American Idol, contestants often wonder if there is an advantage to performing last. To investigate, researchers selected a random sample of 600 college students and showed each student the audition video of 12 different singers. For each student, the videos were shown in random order. So we would expect approximately 1 out of 12 of the students to prefer the last singer they view, assuming that order doesn't matter. In this study, 59 of the 60 students preferred the last singer they viewed. Do these data provide convincing evidence at the 5% significance level that there is an advantage to going last? Okay, so we're talking about proportion. We're talking about what proportion of people prefer the last performer. Okay, so we're talking about P. So for our state, we're going to let P equal the proportion of students, the true proportion of students who prefer the last singer they see. Then we want to test the following hypotheses at the alpha equals 0.05 significance level. And then our hypotheses are h sub o, p equals 1 over 12, and h sub a, p is greater than 1 over 12. Okay, so that's the state part. For plan, we will perform a 1-sample z test for p if conditions are met. We name the test a 1-sample z test for p if conditions are met. Let's check the conditions. Random. It's stated that it's random sample. The 10% condition. I assume 10 times 600 equals 6,000 is less than the total number of students. And the normal condition, the number of successes is 59 and the number of failures is 541, are both at least 10. And that's all you have to do to check your conditions. For the do step, you go to your calculator. You go to a calculator page. So you go to a calculator page and you go menu, statistics, stat test, and we're doing a one prop z test. It asks you for P naught or P0. P0 is your 1 out of 12. It asks you for your successes. Then what does it ask you for? It asks you for your N, your sample size, and then it asks you for your alternative hypothesis. All right, so you put all that in there, you get z equals 1.33, and p-val, which is p-value, is 0.0919. All right, so we conclude. Since the p-value 0.0919 is greater than alpha equals 0.05, we failed to reject H sub O. There is not convincing evidence that there is an advantage to going last. So in this case, there's not convincing evidence that there's a preference. Okay? All right. Can you use confidence intervals to decide between two hypotheses? Yes, you can, but only if you have two-sided tests, only if your alternative hypothesis is not equals. What is an advantage to using confidence intervals for this purpose? Confidence intervals provide more information than just a fail to reject or reject. They actually give you an estimate. Okay, so let's look at an example where we could use a confidence interval instead of a significance test. All right. What proportion of students are willing to report cheating by other students? A student project put this question to an SRS of 172 undergraduates at a large university. You witnessed 2 students cheating on a quiz. Do you go to the professor? The mini-tab output below shows the results of a significance test and a 95% confidence interval based on the survey data. All right, so let's see if we can see what this says. All right, this says it's a test of P equals 0.15 versus P not equal to 0.15. So it was a two-sided test. My number of successes were 19. My total number of my sample was 172. Okay, here's my 95% confidence interval right here. Here's my Z. Negative 1.45 is my Z. And my p-value is 0.146. Okay, so that's all the information that this printout's given me. All right, define the parameter of interest. Well, we're still talking about proportion. So P equals the true proportion of undergraduates at this university who would report cheating by other students. Okay, part B, check the conditions for performing the significance test. All right, check the conditions. So normal or random condition, stated SRS. 10% condition, assume 10 times 172 equals 1720 is less than or equal to the total number of students. And then the normal condition, the number of successes is 19 and failures 153 are both greater than or equal to 10. Okay? The next thing we're going to do is interpret the p-value in context. Assuming p equals 0.15 is true, there is a 0.146 probability of getting a sample proportion of 0.11 by chance alone. Okay? And then the last, do these data give convincing evidence that the actual population proportion differs from 0.15? Justify your answer with appropriate evidence. Well, let's see, my p-value is greater than my alpha, so I would reject H sub O. There's not convincing evidence that the proportion of undergrads who would report cheating is different from 0.15. Another thing I could do is look at my confidence interval. My confidence interval goes from 0.0636 to 0.1573. My confidence interval contains 0.15, so therefore we do not have evidence that it's different than 0.15 because it contains 0.15. Okay, so that's how you can use confidence intervals to help you with a two-sided test. All right, now we need to talk about something called the power of a test. What is the power of a test? The power of a test is the probability of correctly rejecting H sub O. The probability of correctly rejecting H sub O. Okay, it measures the ability of the test to detect the alternative value of the parameter. Okay, so it measures the ability of the test to detect your H sub A. All right, power is 1 minus beta. That's the Greek letter beta, not a capital B that I did incorrectly. It's the Greek letter beta. Power is 1 minus beta, where beta is the probability of a type 2 error. Okay, so 1 minus the probability of a type 2 error gives you power. How is power related to the probability of a type 2 error? As power increases, type 2 error decreases. Okay, will you be expected to calculate the power of a test on the AP exam? No. What 4 factors affect the power of a test? Increasing the sample size, increasing the significance level, increasing the difference between H sub O and H sub A that's important to detect, and block or stratifying sampling. All of those will affect the power of a test.